Good morning, Math Dragons, and welcome to Activity 1.2, Quantities That Change. So please find this in your binder right now. I also pulled out my interactive notebook because it already tells me what independent and dependent variables are. We did that foldable in Zoom. And we have all these fantastic graphs that live here on page 76. So make sure you have all this material out. So I just need the graphs for right now. Now, most of the answers I'm going to be writing are going to go directly onto the graphs. So if you write the answers with me, then you'll be able to answer the follow-up questions that come after this video. All right. If you have a highlighter ready, we can look at some of the important vocabulary together. When one quantity depends on another in a real-world situation, it is said to be the dependent quantity. So it depends on the other. The quantity on which it depends is called the independent quantity. The variable that represents the independent quantity is called the independent variable. This is in our interactive notebook. That is on page 75. And the variable that represents the dependent quantity is called the dependent variable. This is also on page AIM 75. Consider the scenarios from the previous activity. Use the pool party scenario to answer each question. So find your pool party graph. You should already have this graph labeled on the x-axis and the y-axis, and you should have already determined whether it's discrete or continuous. We've done this in previous videos together. It wants to know what two quantities are changing in this situation. The two quantities include the number of teammates who attend the pool party and the number of cookies for each teammate. The number of teammates who attend the party and the number of cookies for each teammate. So the two changing quantities is the one in blue and the one in red. Which quantity depends on the other? Which one is dependent? If you said the number of cookies for each teammate depends on the number of teammates who attend, you are correct. So this one depends on that one. So the two changing quantities are listed on the axes. Being the x and y axis, we already have titles for them. And then we know the one in red, which I illustrated as the y-axis, the number of cookies for each teammate, depends upon the title listed in blue, number of teammates that attend the pool party. Next question. Define variables for each quantity and label them appropriately as the independent or dependent variable. Okay, we could say number of teammates could be n for number of teammates attending the pool party. We could make it that variable. And this is the independent variable. On the other axes, we could label it, give it the variable C for cookies. Trying to be color consistent for you here. So I'm going to turn this, and this could be C for cookies. And this is your dependent variable. Nope, other way. I want you to be able to see it all. So number of teammates is represented by the variable N. It's the independent variable. And the number of cookies for each teammate is represented by the variable C, and it is the dependent variable. Don't lose this information. You'll need it for the follow-up questions. Next, use the fish tank scenario to answer each question. All right, let's find the fish tank scenario in our pile of graphs. In the fish tank scenario, the amount of time draining is on the x-axis, and the amount of water in the tank in gallons is on the y-axis. We already identified it as a continuous graph. The reason it's a continuous graph is because it deals with time. And time can be written in fractional form. It's a nice line, but it's not necessarily proportional. It doesn't go through zero. Right, the two changing quantities. What two quantities are changing in this situation? All right, the two quantities are the amount of time the tank is draining, the amount of time draining, and the amount of water in the tank. All right, so the two changing quantities are listed on the axes. And we did that work already together. So the two changing quantities are listed or labeled on the axes. Next up, which quantity is independent and which is dependent? Well, since we did all the heavy lifting earlier in another video, we know that the amount of time draining is the independent quantity. And the amount of water in the tank is the dependent quantity. Independent, dependent. And I have purposely color-coded it for you so that you can get accustomed to it. You're doing an excellent job. Let's keep going. This looks tough. The equation that represents the fish scenario is W equals 200 minus 10t. What do the variables W and T represent? Well, during Zoom and another activity we did, W is, we're seeing that it's isolated. Usually that's the dependent variable. Let's see if that makes any sense. Would it make sense that the water in the tank is 200 minus 10 times the time it's been draining? Or would it make more sense for it to be the time that it's draining is 200 minus 10 times the water in the tank? Those are the two ways we can say it. For me, the first one makes more sense. So the variable W represents the amount of water in tank. And the variable T represents the amount of time the tank has been draining. What do you notice about which variable is isolated in the equation? Which variable is isolated? W is isolated because isolated means it lives alone. Alone on an island. Poor little W. And W on our graph, the water in the tank, amount of water in the tank, that's the dependent variable. So what do we know? We know the dependent variable is isolated in the equation. All right, so we've taken care of 2 of the graphs. And once we finish number 3 together, you'll have all the information you need to pass the questions that follow this video. So I've got my remaining graphs. I think it should be 4 of them, or maybe, yep, 4 of them. And we're going to go in and find who's independent and who is dependent. I'm going to put it directly onto the graph. Identify the independent quantity and the dependent quantity in each of the 4 remaining scenarios. So, find rainy day. Remember, we've done such a good job color-coding these that we should be totally ready to do this. So, the independent quantity is the time since I left home, independent. And the dependent quantity is the amount of rain. All right, so go ahead and annotate that graph so you have that correct answer. Independent, dependent. Next graph, toy rocket. The independent quantity is the time since launch. The one that depends upon the time is the height of the rocket. That is your dependent quantity. Next up, DVD and game rentals. Your independent quantity is the number of rentals. Your dependent quantity is the total cost. Cost depends upon rentals. Last graph, and then we'll be able to wrap it up. T-shirt sales. The independent quantity is the number of T-shirts. The dependent quantity is total cost. So you have successfully annotated all of your graphs. Very good job. Those graphs live on AIM page 76. We made a little pocket for them during Zoom. And these graphs are used to answer all the follow-up questions that are right under this video on your Google form. Thank you for joining me, and I'll see you soon.